Hello, in this video on Financial Math for Actuarial Exam 2, we'll be taking a look at problem 4.1.17 in the 6th edition of Broverman's book, The Mathematics of Investment and Credit. We'll be delving into kind of a confusing topic, I think. It's partially confusing because there's just so many different terms for the same idea, as you can see here in the problem summary. And there are also three main methods, three main formulas to use. We will use one of them, which is the one you should know for Actuarial Exam 2, at least here in 2017. Maybe in a future year you might need to know other formulas if they decide to make changes. We'll be finding the quoted price, aka also known as the market price or the clean price. There's also a dirty price, which is something different, or the book value of the bond between coupon payments. Okay, so normally we've been thinking about prices of bond right after a coupon payment. Now we're going to think about bond prices between coupon payments. The method we'll use is the semi-theoretical method. It's the most common method to use here in 2017, and it's the one you should know for Actuarial Exam 2. The three methods overall, though, are the theoretical method, semi-theoretical method, and the practical method. Actually, Kellison's book goes into depth about all three methods. I think after we solve this with the semi-theoretical method, which once again is the one you should know and also is the one that gives you the right answer in the back of the book for Broverman's book, I think at the end I'll also talk about the practical method because it's a pretty intuitive method. And in real life, you probably could use any method you want as long as you agree with the seller. All right, so here is the problem statement. You've got bond quotations in a financial newspaper. The quote was given for the price at a date that's going to be between coupon payments, February 20th, 2004. It's an 11% bond with face amount of 100, maturing on April 1st, 2023. The yield is quoted as 11.267%. The goal is to find the quoted price to the nearest 0.001. Again, quoted price could be replaced by market price, or clean price, or book value. All those things would mean the same thing. The quoted price is most commonly what you would see quoted in a newspaper, for example, in the United States. In Europe, evidently, according to Investopedia, they would more commonly quote another price called the dirty price, which is different than this one, which is the so-called clean price. All right, I think what I'll do is first just write down what we know. And then we'll draw a number line and we'll think carefully about the number line and think about what the price should be, thinking about it in different ways. And then we will go ahead and write down the formula to use and go ahead and use it. The formula itself is not that whard to use, but we want to wrap our minds around what's really going on here. So we've got the bond. It's got a face amount, which equals the redemption value, which is 100. It's maturing at par. This is the par value. And what else do we know? We know the effective semi-annual coupon rate, R, is going to be half of 11%, 0.055. We know the effective semi-annual yield rate, which I'm going to call J, as Broverman does, to be half of 11.267%. 0.11267 divide by 2. J is 0.056335. That's going to be J. All right, so we could figure out v to the n power. Well, I guess I should write down n here. Well, let's draw a number line first before we try to write down n. We're not necessarily thinking about this right before the first coupon payment. So in this timeline, let's think of the first moment in time here not actually as being February 20th, but the preceding coupon payment, if there was a preceding coupon payment, would be half a year before April 1st, 2020, before April 1st of 2004. It would be the 1st of October, 2003. The next coupon payment, evidently, since these are half-year payments, it will be April 1st of 2004. The moment in time that we're at is right about here, February 20th, 2004. We are between coupon payments. there's going to be, F times R is going to be 5.5, the coupon payment of 5.5 on April 1st, 2004. The next coupon payment would have been on October 1st, 2004, up an amount 5.5, F times R. Then on April 1st, 2005, there's another payment of 5.5, etc. The last payment is way over here at April 1st, 2023, payment of 5.5, and it's also redeemed. It matures to 100 at that moment in time as well. All right, it's going to be helpful to think about number of days here. Say, first of all, between October 1st and April 1st, and then maybe between February 20th and April 1st, so we can figure out the number of days between October 1st and February 20th, and figure out what fraction that is of the entire period. Hopefully you have the number of days in a month memorized. The number of, it probably doesn't make a ton of difference if you make small mistakes here, but the number of days in October is 31. So from October 1st to November 1st, we have 31 days. Then November has 30 days. Add on 30 to that. December has 31 days. January has 31 days. Technically speaking, February of 2004 was a leap year and it had 29 days, but I think we just want to typically avoid thinking about leap years here. Let's go ahead and just assume it's 28 days, and that is what will get you the right answer in the back of the book. And then March has 31 days. So we've got, oops, that was 151 plus 31, 182 total days from October 1st to April 1st, 182 days. Again, ignoring the fact that 2004 was technically a leap year. From February 20th to April 1st, we're going to have, well, first of all, again, assuming February is 28 days, you're going to have 28 days from February 20th to March 20th. And then tack on another 12 days onto that. There's going to be 40 days from February 20th to April 1st, ignoring the leap year. That's going to leave 142 days from October 1st to February 20th. So the fraction of a period, the period being a half year, the fraction of a period, thinking of it as actual divided by actual, is 142 divided by 182. 142 divided by 182, about 0.78021978, about 78% of a period. I'm going to store this in register 0 on my calculator. Store this in register 0, and we will make use of that. All right, so that's the basic setup. Now, how do you think about the value that we're after, the quote, which again, once more for emphasis, is the same as the market price or clean price or book value? Well, what we could first think about is the price, the book value on October 1st, 2003. Let's go ahead and label that book value, BV, on October 1st, 2003. That'll be the present value of all the future payments at the given yield rate. The coupon amounts are 5.5 again. Multiply that by A and J. What is N? What's the number of payments this is going to be? Well, April 1st, 2004 to April 1st, 2023 would be 19 years, 38 half years, but you'd have to add on an extra one for the first payment. 39 payments is the number of payments at this yield rate per half year, 0.056335. Add on the present value of the redemption amount, 100, V sub 0.056335 to what power would it be? Going back 38 periods would bring you to April 1st, so go back 39 periods to get back to October 1st. Raise this to 39th power. So let's go ahead and calculate that. That'll help us get our bearings here. So let's see, 1.056335 is 1 plus j. The reciprocal of that is v, raised to the 39th power, subtract from 1, divide by 0.056335. A is about 15.657. Multiply that by 5.5. You get 86.11378. I won't bother writing that down. I'll store it in register 1 here for the moment, though I might store some other things in that register later. So this is going to be stored for the moment in register 1. Now figure out this one to the 39th power times 100. I won't bother storing that. I'll just add that to what's in register 1 plus recall 1. The book value on October 1st, 2003 is 97.91 if you round it. I'll go ahead and carry more decimal places as I usually do. Okay. Now, if we imagined pushing this forward in time by half a year, we would get to the book value on April 1st, 2004, right before that coupon payment. So we could think of the book value on April 1st, 2004 as being well, we could think of it in two ways. We could think of it as the present value of the present value of the remaining payments essentially right before that payment here on April 1st, 2004. We'd have to use an annuity due instead of annuity immediate if we did that. We could also think of it as pushing this amount forward in time, 97.909,78369, by the growth factor, which would be 1 plus j, j being this thing here. So that would be 1.056335. Raise it to the first power, multiply by that, and then subtract the coupon payment. Okay, well that would be the amount, the value right before the coupon payment. Value right before coupon payment. Sometimes called the dirty price, especially if it's a portion of the period instead of one full period. And then subtract off the coupon amount, subtract off 5.5. That's the coupon amount. To get the book value on April 1st, 2004. Let's go ahead and do that. So I'll multiply this by 1.056335. The book value, so to speak, right before the coupon payment, which is actually, well, I shouldn't have used book value. The dirty price right before the coupon payment is 103.43. Subtract the coupon payment, 5.5. Get 97.9255. 3136, of course you'd round that. Okay, so that would be the book value right after that coupon payment on April 1st, 2004. You should check this on your own, could find that as the present value of the remaining payments, including the redemption amount, not including the 5.5 here on April 1st. Think about it as an annuity immediate. You should confirm that you get the same thing. What we want to do now, as far as answering the question to find the quoted price on February 20th, the 78% of a period through this period here, is we essentially want to mimic what we did here, except instead of a first power there, we want to use the fraction of the period, the 0.78, and instead of the full coupon payment, we want to use what you might call a pro rata coupon payment, a proportional coupon payment. Multiply 5.5 by 78%. Okay, so that's going to be giving us the price that we want on February 20th, 2004, according to the semi-theoretical method. I'll still call it a book value because that's another common name for it. It could also be called the market price, could also be called the clean price. We go ahead and just write it as dirty price. This is going to be at the clean price, what we are after, minus the accrued coupon. The thing that makes this semi-theoretical is the dirty price is computed theoretically with compound interest, essentially, and the accrued coupon is a more practical kind of thing, less theoretical. It's based on a direct proportionality. That's why they call it the semi-theoretical method. The dirty price is going to be 97.90978,369. Promote that forward in time by multiplying it by 1.056335 to the power equal to this, 0.78021978. Subtract off the accrued coupon, thinking of that as being 5.5 times the same fraction, 0.78021978. Okay? That's the method to find the answer according to the back of the book in Broverman, and also according to how you should do it on the Actuarial Exam 2 here in 2017. So let's go ahead and finish this calculation now. 97.90978,369. I shouldn't have typed that. I'll store that in register 9 for the moment. 1.056335 raised to that power which is stored in register 0, raised to the power that's in register 0, gives us approximately 1.04369. Multiply that by what's in register 9. So the dirty price is 102.1872295. I'll go ahead and store that for the moment in register 01. Multiply 5.5 times what's in register 0. This is 4.29120.879. Subtract that from what's in register 1. We get a clean price, a book value, a quoted price, a market price of 97.896. And that is to 3 decimal places to the nearest 0.001. And that is the correct answer. Now, there's something strange about this answer if you think about it compared to what else I have here. This price is less than the book value on October 1st of 2003. Okay, the semi-theoretical method, though it is the most common method used, does lead to what you might call anomalies. This clean price, this quoted price, is smaller than this price here on October 1st, 2003. Evidently, this bond was bought at a discount, so these prices should be rising ultimately to 100. Now, I was interested in understanding how that happened a little bit more on my own here before I made this video. And what I really ended up doing is I ended up graphing essentially this thing as a function of time, where t is between 0 and 1, where this was replaced by a t and this was replaced by a t. And what I ended up seeing with my technology is a graph that was actually concave up. It increased from time 0 to time 1. Ultimately, if you only look at the endpoints, it was higher over here than it was over there, just like this number is higher than that number by just a little bit. But it was a little lower in between. It was a concave up graph that actually decreased a little bit. Okay, so weird things like this can happen with this semi-theoretical method, but it is the method you want to use. Let me end the video by just thinking about the practical method. Even though it's not a method you should use, at least here in 2017, it is more intuitive once you have these two numbers. Essentially, the practical method is just a linear interpolation between those two values. So it would be taking 97.90978,369, multiplying that, I always have to think about this carefully here, by, let's call it 1 minus k, where k is the fraction of the period, the 0.78. Call that k. It is commonly called k sometimes. It's called that in Kellison's book. And then add the other point, 97.92553,136 times k itself. This is going to be a quantity that when k is 0 gives you this number, because when k is 0 that's 1 and this is 0. And when k is 1 it gives you that number, because when k is 1 this is 0 and that's a 1 times this. So you just get this number when k is 1. And for something in between you get something directly in between, along a straight line really between the two, like that. So I'll just go ahead and plug in k now into this. We will get a different answer that really in my mind makes more sense, but so k is in register 0 here. Let's take 1 minus what's in register 0. That's 1 minus k. Multiply times this, times 97.90978,369 to get that. I will store that in register 1. Now take 97.92553,136, this number here, times what's in register 0, what's times k, to get that, 76.4034. Add that to what's in register 1. So the practical method would give an answer of 97.922, which is between these two numbers, really as it should be. Okay? So the practical method gives you what you might say is a better answer, but the one you want to use here in 2017 is the semi-theoretical method. Okay, use that for the exam, unless they change the rules in the future, okay? And you should watch out for that.